Hello everyone, welcome back. In this part of the tutorial, we will be focusing on the columns that are at the end of the wings, which are these three, as you can see here. If I can pull up, which are basically the three that you see at the end of every of these wings. So that's what we're going to be focusing on. From the last part, we finished our setting out for all the three levels, all the three blocks. And in this part, we're going to be continuing on using those that we've set up in the previous video. So my idea, or the way I want to approach this, is basically I'm going to take a pen. What I want to do, because we all know these arcs are built from the same set of components. We just call one away each time it goes up to a different block. So what we're going to do is, let's say we take this for example. We want to take this block. We can find the center point, and what we want to do is basically draw two sets of lines, and those lines will dictate where the columns will be. So that's our plan of approach. And now we can set that into motion. Okay, first off, let's actually, since I know I will be needing those, is it easier to get it from this, or should I just not? I think it will be easier. So what I want to do is, let's create another one here, and this time we're taking it from that one because it makes it easier for us to select this one, the arcs that we actually want. So we actually don't need this this merge right here. We can actually probably delete that merge. Okay, so let's call this main setting out, or let's just call this main arc, since there are arcs. Main arc setting out, something like this could make sense. And these are basically our secondary arcs. So we're gonna set this one also here, and then we're gonna call this secondary arc setting out. We can get rid of the outlines since we know what we're talking about. Let's add all this to the group. I think we can disable that, and let's see. Yeah, okay. So we have that. We have this. We have that. Well, there should be enough. Oh, we're missing one other thing, which is quite important. Or maybe I won't be doing here. What I want to say is the offset. I think it's about time we create the offset parameter. But wait, let's connect these out first. So let's disable the wiring so that we can be a little bit tidier. Okay. So this is going to be for our first column. So we can actually disable that. Okay. Let's start. This is the main arc, and the tree structure is basically the same. Should probably simplify this, and so I don't have to simplify it here. This one is already simplified, so that's fine. Okay, we're gonna do a. First, we're gonna get the middle point for the curve. So we're gonna do a CRV evaluate, curve evaluate, and we're gonna reparameterize this, and we're gonna take the center point from that. So with that being selected, can we get a center point from this? Well, we know the radius, so we can just say, or actually, we can do a deconstruction of arc. Although, for the deconstruction of arc, I do think we need an arc, but these are not arcs, since these are including the straight path, you know. Is there anything else that we can use? Curvature, maybe. Aha, yeah, this one. Curvature basically is used to analyze curvature as at a specific parameter. Uh, yeah, at a specific point basically. So we can do the same here. I can say I want the center of that. So that gives us the arc, which we can then use to deconstruct it. It's a little bit double work, but yeah, this is one way we can be sure that whatever comes in here will go through the same process, and thus providing us the data that we expect it to have or to provide us with. So now that we have, this is basically a base plane, but you can also turn into a point. We have the radius, which we already have as a parameter in the beginning. We have the angle of the arc itself, which is not something that we'll probably need, but the angle is something that we need. So we can actually use that point. Let me try. Let's do a vector 2 points. We're going to be connecting the center point to the point that is in the middle. So let's visualize our vector. This is the V. The anchor point can be this one. Oh, looks good. Looks very good actually. Okay, so now here's what we want to do. Since they're all going to be the same, I want to be focusing on one of these. So let's say we focus on this one. What I want to do, since we have this point, I want to have a parameter that says how many columns I have. So let's say for now it's 3 because that's what it is in the real tower. I want it to be in this way. And how we're going to set up these towers, these columns, basically, like I explained, we will draw 2 of these, 2 for each, so that we can easily scatter the curve afterwards, and then we take that as our columns. One thing to note is, in order to achieve this divisioning, we're not going to be using divide the curve by 3 or 4 or whatever the case is, because that will give you unexpected results if you change certain parameters. What I suggest is we make use of step angles to be precise. And what I mean by that is step angles are a little bit more predictable than trying to divide this by X amount and then you have to adjust it if your curve is bigger or whatever the case. It all seems to me less controllable, so that's why I'm going to utilize step angles instead. And here's how we're going to do it. We have one curve. So before we start, I want to get 3 for each of these. Oh, I should not have done that. Something like that. I want to get 3 that sits in the middle of our column. So we have this one, and we can say, actually, let's create a domain first. A domain that suggests how far this should stretch. So let's say I don't know, 30 smaller than 80. I'm gonna call this angle domain. Or no, let's just call this max angle because that's what it is. Max angler? No, max angle. Okay, so this will go here and here. This will be a 30 to 30 domain. It's not what we want. So what we want to do is, since we want to say, if I have a max 30, I want this whole thing to be 30 and not 60. If I were to do this in a minus, you know. So what I'm going to do is I'm going to say minus x divided by 2. And the other one is just simply x divided by 2. Wait, something's wrong. What did I do there? Oh, that's minus 2. X divided by 2. So this will give us a total domain of 30 because minus 13 to 15 is 30. Okay, now that we have a domain, we can do a range division actually, which takes in a domain and how much you want to divide it. I should probably leave this panel up here. I keep on deleting it by automatically. So, all right, let's say 3 or 2 is smaller than 5. So you can have how many columns you have? Number of columns. So let's set it to 3, and it goes in here. And we have to do actually x minus 1. This is, so let's set this to a bit of, let's say, I don't know, 50 or something. So this is going to be the division that we expect. And now we can use this to rotate our vector, which is this one. So the main vector we want to rotate is the one we created, obviously, which is the green one. So that one goes in here. How you want to rotate? Well, we want to rotate them by the z-axis, obviously. So that one goes in here. We do have to specify, I'm not sure, but I do think that we have to specify the point of where we want to rotate this. Okay, now this is getting out of hand, so I'm gonna clean that up and get that away. But we'll see. But if we do need to have a specific point inserted into the z-axis, because right now it's saying it's just a vector, you know. So we'll see how it goes. We might have to fix this one, but then we can just connect that one, so that's no problem. And now, let's see. Let's check our data structure one last time. There are 3 branches, each with their own. We might have to graph one of these because we want each of these vectors to be rotated 3 times according to this one. And if I were to look at this tree structure, yeah, exactly. We're not really getting the results we want. So that just means that we have to graph this one, and we are still doing something wrong, it seems. How come? Or am I not crafting the right one? Wait, let me see. Let's troubleshoot this. Actually, we do have the data that we want. The only reason we're not seeing that is because, well, our vector display does not match. We have 18 values here, which is something that we also expect because we started out with 6. 3 here, 2 here, and 1 here. And well, 6 times 3 should give you 18 values. And we do have 18 values here from the output of V, as you can see here. So that's actually correct. The only thing we're seeing is because the A anchor point is still looking at the 6 values that we initially have. So what we can do, well, it's just for visualization. What should we do here in order to increase that? Let's try trimming the tree deck down to the same data structure. Let's simplify that one. Yeah, that's not gonna work. Still, we have how many there? 9 for the first branch, 6 for the second, 3. That's still not enough. So what you can do is probably just duplicate, just for the visualization, perhaps. Because the data is there, we don't really need to see. Oh, we do need the point actually. So we need we do need to fix this. Alright, data to duplicate, that one. Number of duplicates, that should be 3. What's the O? Retain list order. We might have to fiddle around with that for a while. Number of duplicates should be 3. Because that's how many columns we want. So now, what do we have? 9, 3. And now if I do this, I think the list order is wrong, that's why. There we go. Okay, so remember to set the retain list order to false because we want to retain, because now right, what it did is it, for example, here in this point, it will start in 0. Let me, oh wow, what is that? So what it did here is we have 0 here, 1 here, and 2 here. And what it does, it basically duplicated according to this list. And then, well, 3 will come here, and 4 will be here, 5 here. And then with the retained list toggled, what we get is 0 here, 1 here, 2 here. This order is then changed. Instead, you will get 1, 2, 3, 0, 1, 2. 3, 4, 5, 6, 7, 8, and that's what we have ordered for our vectors. So that's what we also need for a point to have. Okay, with that settled, we can now safely say that these two will work together. We have our curve. Now this is only, remember, the main curve, and you can actually use the domain to sort of like change how your column should be looking like. We're going to actually apply a secondary vector rotate. This one. We're going to do it obviously on this one. It will also be rotated in the... Actually, I can just internalize this. I mean, I don't really need to see that. I mean, it makes no sense to rotate it these vectors other than around the z-axis. So that's all get rid of it and make it a little bit cleaner. This is not gonna be changed ever, so that's fine. We're gonna put this to degrees. Let's try this out first. Let's say we want a rotation of minus and plus a certain degrees. Let's start with 4 and 4. We're gonna see if this works, and then we can build this into a parameter where we can control. Probably gonna be the same as this one, but let's quickly test this out first before we do anything else. So these two values again will have to be applied to every factors in here. So we're gonna be grafting this one. Starting off, we have 18 vectors. In the end, we expect to have 18 times 2. That will be 36. Ooh, please, my math, please be good. Yeah. Do I need to duplicate these points again? Perhaps. Do I? Wait, let's just do a list SDL from those points using... Let's see the data structure. Yeah, the data structure of these needs to be different. I do think we need to duplicate these points. So it's not just going to be 3 times the column, but the column is going to be made up of 2 vectors, so it has to be x times 2. Yeah, this one is not right anymore, but we can. Actually, let's look at the T structure. 18, 12, and 6. So we have to trim this tree. So that we have 18, 12, and 6. Yeah, this is what we want. So if you were to plug the newly trimmed tree of our vectors to our direction, the length, what are we going to do with the length? The length is actually the radius. I recall the radius coming from this one, but I only need one. I mean, the radius is going to be the same for every one of them. So do I need to? All right, let's do it like this. Let's just say radius and flatten it because I only want one number. They're all the same. It doesn't really matter. If you don't believe me, let's check it out. Radius, they're all 15. Doesn't matter. So we just want one number, and that's going to be our length. And there we go. And now, do I still need this? I don't need this. No. Oh, we should build this one. So let's say, let's create a slider called step angle, and we're gonna be 2 to, I don't know, 7. Well, it's adjustable, so I don't need to decide that now, as if it's not adjustable. And it's called step angle. We're gonna be doing the same thing actually. So let's copy that one. Let's put this one here, and this one goes there. So the total step angle of 2 degrees. Ooh, what happened there? Not enough? Data conversion failed from text to number. Oh, right. Okay, then you need to be a number. So let's put it in a number in between there. And there we go. Yeah, we fixed it. What happened here now? This is, oh, it's a domain. Oh yeah, of course that's not gonna work. I'm being stupid here. Let's do it like this. So you're gonna get rid of that. We don't actually need that. And what we're gonna do is put a negative value in here, and then we're gonna actually create a number value again. And this one goes here. This one goes here. So now we have a step angle of 4. So 2 times that. So we need to modify this. I don't think you can do expression here. That's why I have this negative value here so that I can. Oh, I can't do a negative value. Well, doesn't matter. I'll just create another one of my number, and then I'm gonna do here minus x times x divided by 2, and the other one will be a positive x divided by 2. So now I can say how much these should expand, and this is going to be controlling our how much the column should be divided. So if I were to say I want 5 columns, well, now you have 5 columns, and now you can expand this. So let's get that to, I'm not sure what the original, but I'm gonna stick to like 60. Step angle, I might increase it to 15 actually. Depends. So let's leave that at 8. That sounds a bit right. And what I'm gonna do it here now is I'm gonna actually make the column just this one. So we're gonna do a what's this? Main arc setting out. Main arc setting out. Okay, main arc setting out will be. Wait, what arc am I selecting? Why is this? Oh, okay. Let's leave that off. And we're gonna do a what's that called? Intersect between curve and curve. This one and a new curve. Ooh, that's not good. Something is not right. Interesting. Oh wait, but we don't need that. Actually want a single curve. Interesting that it's not selecting. Okay. I think the reason is if you look at data structure, in the first branch we have 3 items, and in the first branch here 0, 0 have 18 items. So there is obviously some form of inconsistency of data here, or the line's not touching. Is that right? I don't think so, but let's try x plus 1 just to make the lines a little bit longer so that I know for sure that they should touch, and they are not touching, so it's not that problem. I'm gonna get rid of, I'm gonna do Control Z. Okay, So we do need to join these one way or another, which is fine. We can do that here. We can join the main arc with the not main arc, the secondary arc, so that we can have a nice data. And now we can say join our curve into one item per tree. And what we can do with this, I can move it a bit here. Where's my? Okay, so now I'm going to switch you to A. I'm going to switch you to B. There we go. Because now there's only one curve to exercise all items here, so you can't change. There's only one item, you know. The fun part is now if we shatter this, we want to shatter these curves, and they got into the A, so I want the A parameter. Notice how I'm not reparameterizing any of this, okay? That's very important to do. If you reparameterize any of these, then the parameters will not, then you have to reparameterize the whole workflow. So not reparameterizing it also works because, well, we're taking the exact same length and applying to the exact same shatter. Now, I just need to call pattern. I'm going to use call pattern because, oh, something is not right. Aha, okay. There's going to be a problem if we don't fix this. So let's take a look at our lines that goes in. Okay, there's our 3 branches that we expect, but let's have a look at our T parameter. This does not look like 3 branches to us, more like 36 branches. So we need to, let's see what it looks like simplified. Okay, so we need to trim the tree back down by 1 level. Not simplify because I already have to simplify on this one. So I'm going to simplify that one. If I plug in this one, hey, what do you know? You get the same data structure as that one. So that should give us 3 branches here. I think we might need to simplify that one also in order to get the right one. Or not, actually. How does it look like simplified? Interesting. Okay. This might be problematic for us. If I do this, let's test this out. Let's make a calling pattern that's on and off, meaning true false. Let's see what we get. Where is that line? Oh, we need to simplify that one also. Wait, what? Oh, all this time I'm calling the wrong line. Why am I calling this the straight line? I want to call the circle. And it's from B, not A. Sorry about that, folks. But the same applies here. So let's do this one here. Here we go. Yeah, then I don't need that here. And if I do that, true, false, what am I selecting? Why something is still on, I don't know where. This one, okay. Hey, there we go. We got it the first try. The error that we made was we were trying to call these, but why are we shattering these? We don't need to shatter these. These are something that we used in order to create the shatter for this. So we've been shattering the wrong curve, the wrong input. We need to shatter this one because that's where we want to extract our column curves from. And if you after the shatter, and if you put in a this is a call pattern, true false, I enter true false because, well, it's something that we expect. If I do a CRV evaluate just on this, just to give you an idea, let's just create a point here. For example, this is the middle point. right? Well, there's only one way that this can work. It's either false true or true false, you know? I mean, there's no other way. I mean, it's either you want to keep this and not this, and keep this and not this, which goes all the way until it hits this, not this, and this, and not this, and this. You know, so it's on and off. It's not like you will have two times curves that you don't want. There's always an on and off pattern here that you can easily manipulate. And what I did here is basically just call on and off. For example, if a curve happens to be for some reason starting in a different way, and you end up with let's say something like this, that you're missing the bits that you actually need. Well, the only thing you need is to right click on a P and click invert, or you change your text. I mean, for this we can use some sort of logic in order to for Grasshopper to select like I don't want to use this, but I want you to find out that point there. I want you to look at its length compared to all the other ones, and if it's the same, then it's the one that I want to keep. That will work. That can work, but it costs you probably a lot more components than just two. So sometimes you have to be smart about how you engage certain situation and when to sort of like put these what I would call these static inputs. You know, I mean, for us, it's just one toggle. It's not gonna be multiple options. It's only one or the other. So if it's not the way, you just come here and toggle it. That's it. It saves you time and it saves you a lot of headache, to be honest. Okay. With that said, we have our the first column. The next thing we want to do is we want to have a parameter that we can use. Actually, let me turn this on for now. That we can use for our balcony. So I'm gonna make a new slider. Our balconies can be 1 meter minimum depth to, I don't know how deep are balconies normally. 6 meters? Oh wait, that's a lot. 5 with a decimal. I'm gonna call this balcony depth. I'm actually gonna copy this, Control X, cut this, and put this all the way here because it is a main, what do you call it, main parameter. And I'm gonna copy those two, and I'm gonna do click Alt once. If you don't have Rhino 6, then just rename them. Make sure that they're all connected though. I'm gonna keep this add to group, and I'm gonna copy, and then I'm gonna paste one here by using Control Shift V. If you just do Control V, it'll paste it. Watch. So I still have that in control. Okay, let's do it here. Actually, if I control this and I move here, let's say you're far away from the point where you want to paste it to. If you just do Control V paste, it'll just keep on pasting like that. And then you have to come in here and like move this all the way to wherever you want to use them. Another quick way is to just, if you want to copy this and let's say, oh, I want to use it here, like right here. What you can do is Control Shift V, which is a sort of paste in the center of where you're looking at, which can help you a lot of dragging and probably have less duplicate, because you might have pasted something and you can't find it, you paste it again, and then you can't find it and you paste it again, then you drag it, and then you leave those orphaned somewhere buried in your script. Anyway, where was I going with this? Oh, right, the balcony. So if I do an offset curve, we want to offset the curve that's combined, that's joined, and the depth is that one. Now, is it going outside or inside? It's going outside. Then we just do -x so that it goes inside. Now we can actually do the same thing. We copy that one, we put this one here. We have to, this is the B, we have to do that. And again, we have to shatter this, obviously. The shatter should now go from the offsetted ones. So if I were to disable all that, why is this one not having a... That's weird, isn't it? Oh, this is disconnected. That's well, that explains. Okay, let's have a... Okay, that should be fine. I mean, we are all using this as a intersect, so that's fine also. There we go. Now this is what I want. Okay, now to combine this is going to be tricky. So I'm going to bring up my param viewer in order to see what am I dealing with. Uh, it looks like if I just merge these two together, it should be fine. But is it? I think one of these has to be flipped, but I'm not sure. So if I were to merge these, like I have done here, and as I connect these two curves together, right? Because ultimately what you want is have a curve like that connected, and oh, that's your column. That's the end result. That's what we want. We're so close. And we say connect. Wow, this is not exactly what I was expecting at all. Why? Well, that looks nice. Let's do position instead. This, I have no idea what this is. Okay, that's not working well. Meaning we have an error somewhere, and I do believe I know where the error is. It's because the way um, it actually stems all the way back to who's taking lead. For example, if I were to say list item from that one, what am I selecting? I am selecting one there, one here, and one here. Which is actually fine. What's this one then? Strange that it's not select. Oh, aha, right. We're trying to connect. I can't. We're trying to connect 18 items into this one. What we actually want is these two to connect, these two to connect. So need to make pairs, basically. How are we gonna do that? Well, I think it's about time we use a different component which is called weave. And weave can be found under set weave. What weave do is it creates a list ultimately from items according to a pattern which is the P, and I think it's default set to 0, 1, so it will whatever you give into here, it will take that one, put it here. It will, whatever comes to 1, it will put at the second component, second item, and then it will take 1 from 0, and then 1 from 1, and then it will basically alternate depending on what you set here. So, but if you were to say 0, 0, it will take 1 from 0, the second also from 0, and then the third from 1, and then the next one from 0, and that's on 0 again. So that repeats. But the default should be fine. But before we do that, I think we might actually, let's test how this goes. I want to have 3 still. Okay, that's good. And now, what I want to do is I want to say partition the list. I don't need this anymore. Into groups of 2. So I'm going to say S is 2. And now if I connect this, they're working a lot better, except that now this happened. And that happens because the curve direction is one goes here, okay, and the other one also goes here. So what curve connect does, and I've set the G to position, meaning just draw a straight line. What we want to flip this curve to go here, so that when it connects, it will go like this, 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 and back. So now it's doing the opposite. It's now going like this, and since the other stop point is here, it will go out here and then there. So let's flip that real quick using, oh, using a flip curve. Easily solved. And the flip curve can go either to one of these. It doesn't matter which one. So I'm just going to put it into the bottom one. Put that in, and there we go. Fixed. Oh, whoa, oh, no. Should be careful with that. Yep. You can actually play with this, but unless you want this kind of columns, then yeah, go ahead. Or using curvature, but that's not what we want. We want to put this in position. We want a straight line. And if I were to enable our own column and have a play on the balcony depth, that's like, I don't know, 3.5 perhaps is looking more likely. There we go. We have our first columns. Well, not first column, actually all the columns for our towers. The reason I'm doing this in one go instead of separating is because if I look at, let's have a look at these pictures again. Do I have one that's, okay, let's do World One. Remove the plan. I think this is a good one. So what you see here, you know, these are the three columns we just created. They are the same in all levels, but that's why I can create them in one go. And in the next video, what we're going to do is we're going to tackle these secondary sort of columns. And you can see that the first one matches all the way down, but the second one doesn't really match up, and so it goes on. Well, this cannot match up anymore because there's no more columns above this one. So that's why we're separating the main columns. That's why we're calling this the main arc, the main columns, from the secondary columns. I think I have more picture that show this, but I'm not sure anymore. Can I see it here? I can see it there. This one, maybe? Yeah, so you can see this one matches all the way up. And that's why we're separating it. Okay, well, that was, I failed again. That was another long video. Damn it. Not what I wanted to do. But at least I hope you understand, or can understand a lot better why we're doing this, what we've done here. Because the important thing is that you understand what is going on. It's not you trying to follow me every step of the way without understanding. Then defeats the purpose of me making this video. Okay, outside that's, well, we'll stop it here, and in the next one we'll continue on with the secondary columns. So I'll see you in the next one.